Okay, so first things first. Somehow, school comes to an end next week. I don't know exactly what your timetable is showing when you're supposed to have your physics exam. When are you supposed to have your physics exam? Does anyone have an idea?
I've just joined, so I don't know. What are you asking?
I'm asking when you're supposed to have your exam, physics.
It's showing on the 18th of November.
On the 18th of November. Okay, so my suggestion is, even as school comes to an end, we continue having these online tutorials up to when is 18th of November? Which day is it? Let me check. Yeah, 18th of November will be on a Wednesday.
I think so.
I think it will be on a Wednesday.
Correct.
Yeah.
Wednesday.
Yes. So we continue having these tutorials up to maybe a day before or the exam, then we call it a day. The reason is because the exam is going to be such that you are going to be asked things based on what you have learned, based on where the quizzes have gone. Because right now, I think you are about to start. You are supposed to have your quiz number 12. I think that is
Yes.
yeah. I don't know whether it's this Friday or next week, but your quiz number 12 is coming. So the exam, you cannot be examined on things which you have not been taught. So wherever the time comes where you end, that's what the exam is going to be based on, and that's what you're going to be assessed on. Okay? So hence my suggestion that we continue to have these tutorials, because whatever we cover during these tutorials, one of those things is going to come in the exam. Okay? That gives you a chance to at least be in a position to successfully attempt some questions and know how to answer them properly. It's going to go a long way. Your time is going to be worth it, and the stress of whether you kind of answered the problem correctly or you did not answer the problem correctly it's much ways. So I would encourage you all to invest your time, some of your time. You have that 1 hour, those 1 hours, you invest them in the tutorials. I think when the exam starts, the Tuesday tutorial, which we have, this Tuesday tutorial, will have to be squeezed into 1 hour, then it will have to be shifted into the evening. Because maybe during a particular day, a Tuesday, you're having an exam during the day. So we can't have a tutorial. So the Tuesday tutorial, probably after next week, we'll have to shift it to the evening so that we can continue the 1 hour in the evening, 1 hour in the evening, 1 hour in the evening. It's going to go a long way. Okay? And the other thing I want to suggest is, I think you might have a choice. In some, there'll be multiple choice questions, then there'll be long questions, but in the long questions, I think you might have a choice on which questions you're supposed to answer. I would encourage you to try to attempt questions you are familiar with. And that might imply questions where we have looked at tutorial questions, topics you have looked at. So maybe if that becomes familiar, then you can try to attempt those. I think the trick is if you can answer complete questions. If you can answer a question completely. Answering bits and pieces here and there doesn't really help a lot. But if you can answer a question completely, that goes a long way. Okay. So let us see what we can do today. Hopefully by the end of this week we can complete this tutorial sheet so that next week also we can complete another tutorial sheet. Then yeah, we keep on moving like that until we run out of time. So yesterday we looked at this tutorial sheet number 1. That's what it is, and that's what we found. Last week we looked at tutorial sheet, question number 2, but last week I forgot to press record. I forgot to press the recording button, so I don't have a recording for that tutorial question number 2. So I'm just going to go through it quickly for those people who did not attend but have found time to attend today. So basically we had the track which was moving at 22.5 meters per second, and it decided to decelerate with a rate of 2.78 meters per second. So how much time did the track come to a stop? Well, the track was moving at 22.5 meters per second. That was its initial velocity. When the track came to a stop, something which was stopped has got a velocity of 0 meters per second. So the final velocity of the track was 0 meters per second. And the acceleration, it says decelerate. So that means negative acceleration. So the acceleration is negative, and that is minus 2.27 meters per second. Then how much time did it take to stop? So you're looking for time. So the formula we use is that one. The one we know for acceleration, a is equals to v minus u divided by t. Then we make t the subject of the formula. We end up having t is equals to v minus u divided by a. Then we just substitute the final velocity, which is 0 meters per second, the initial velocity, which is 22.5 meters per second, divided by the acceleration, which is minus 2.27 meters per second squared. When something slows down, the acceleration is negative. When something speeds up, the acceleration is positive. So that's something to notice. So if something is coming to a stop, definitely the acceleration has to be negative. And we kind of like drop the units so that we have a more compact thing, and we end up having with a time of t equals to 9.9 seconds. Then how far did it travel in this period? So now that we know the time, we know the initial speed, we know the acceleration, we could use this formula here. S is equals to ut plus half at squared to work out how much distance has been covered. That's one way, as we are going to see. So you substitute here with 22.5 meters per second times 9.9 plus half, the acceleration is negative, minus 2.27 meters per second times 9.9 squared. If you drop off the units, you end up having this 2.25 times 9.9 plus half minus 2.27 times 9.9 squared, and you end up having this much distance. Now, another way to work out the problem is to use this formula here. S is equals to half, then u plus v multiplied by t. This also gives you a rough estimate of what the distance is. If you know what the initial velocity is, what the final velocity is, and how much time it took for you to make this change from v to u there. So S is equals to half, then the initial velocity is 22.5 meters per second plus the final velocity is 0 meters per second times 9.9. That gives you 111.4. So you can see our 111.4 and the other one 111.5, it's very, very close to each other. Basically, they're practically the same. So even a simple formula like this, S is equals to half u plus v t, actually gives us a very good estimate of how much time or how much distance was covered. The third part, C, how far does it travel during the 3rd second after the brakes have been applied? Now, to work out this question, yes, we're talking about distance, but for us to find out how much distance does the track cover in the 3rd second, we need to find out how much distance the track has covered after 2 seconds. Then we also need to find out how much distance the track has covered after 3 seconds. Then we subtract the distance covered after 3 seconds minus the distance covered after 2 seconds. That gives us the distance which the track has covered in the third second. So we proceed with the same formula. S is equals to u t plus half at squared. In our case here, the time is after 2 seconds. So with that, we work out the distance traveled after 2 seconds. The acceleration is the same, it hasn't changed, but the time is 2 seconds, and that's what we do there. And we find that the truck has covered a distance of 40.46 meters. We again proceed to work out the distance covered by the truck after 3 seconds, and we come up with a distance of 57.3 meters per second. If you look at that calculation there, then the distance covered in the third second is basically the distance covered after 3 seconds minus the distance covered after 2 seconds. That is S is equals to 57.3 meters minus 40.46 meters, and that gives us a distance S of 16.8 meters. So in the third second, the truck covers a distance of 16.8 meters. So basically this was about question number 2, which was not recorded. This time around I have pressed the record button and people can try to follow. Okay, now the objective of our tutorial today is to look at question number 3, number 4, and possibly question number 5. 3, 4, and possibly question number 5. Okay, question number 3. What does it say? It says a ball is dropped off a cliff and 2 seconds later another ball is thrown vertically downwards with an initial speed of 30 meters per second. How long will it take the second ball to overtake the first ball? So again, this problem is it's a distance problem. For you to overtake something, you need to have covered the same distance, not necessarily the same time. If, for example, you are driving from Lusaka to somewhere Kabwe, let's say, okay, your friend starts off at 7 hours. Then I don't know how they're driving. Then you start off 30 minutes later. Okay. You can overtake that person. Okay. For you to overtake something, it's not how much time you've been driving. The time you've been driving doesn't need to be the same. The other person could have been driving longer, for a longer time. The other person could have been driving for a shorter time. Okay. For you to overtake somebody, you need to reach a stage where you have driven for the same distance. That's when you can overtake someone. You need to have covered the same distance. Okay. So in this case, we need to work out what the distance is, but the time is related. How much time is going to take is related because there is a time difference of 2 seconds. And the other ball has got an initial velocity of 0. The other one has got an initial velocity of 30 meters per second. So basically that's what you need to do. We need to take that into account. We need to take it into account the fact that for an overtake to happen, or for the two balls to reach overtake each other or something like that, they will need to have traveled the same distance, but there is also a time difference of 2 seconds. So we've got two balls. Just a minute. So we'll discuss what we know about the first ball. And the second ball. Just a minute. Okay. So the first ball has an, what is the initial velocity of the first ball? Yeah, 0. Zero meters. Second, and is falling towards the eighth. So what is acceleration? A is 9.8. Okay, so the first ball has an initial velocity of u1, which is 0 meters per second, and is falling towards the surface of the eighth. Therefore, its acceleration is 9.8. Yeah. It falls for a period, a time period. Think t. By the time it is so the distance covered is u1 t plus so that's how much distance we can work that out. That is 0 t not in here there is 9 point. So half times 9.8, that gives us 4 point something, 9.8 meters per second squared. good. What we got? Okay, there. That gives us then what? Okay, so we have that as the distance covered by the first ball. Then the second ball is dropped 2 seconds later. So I think this idea of 2 seconds later, we'll have to express it as t. So the second ball is dropped 2 seconds later with initial velocity for the second ball. U2 30 meters per second. Meters per second. Velocity towards just a minute, towards the surface of the Earth. That is acceleration. Is so
I can't see anything.
okay, then so I think we can express the time of the second ball. Second ball in relation to the first ball as t plus, I think t plus 2. If it's t plus 1 and t minus 2, then we'll make a change. We'll get things which don't make sense. If we're correct, then we'll see that things, because it shouldn't take a lot of time for the second ball to overtake the first ball. So if our t plus 2 is correct, then we'll get something which makes sense. Otherwise, we'll get something which doesn't make sense. Okay? Then we'll have to change. Okay? As follows. Thus we get the distance covered by the first, by the second ball, as something like this, I think. Otherwise, if we get some stuff which doesn't make sense, we have to use t minus 2. One of these is correct. It's either t plus 2 or t minus 2. Yeah, but I think it's t plus 2. Is it clear why we're doing this?
Yes.
Yes, you're trying to relate the time for the second ball to the time for the first ball. The second ball comes t plus 2 later, so I don't know. I think later can be mathematically, we can express it as plus. I'm not sure whether plus or minus, but we'll see. If we get something that makes sense, and I have got what the answer is supposed to look like here. If we get something that makes sense, then we have to change. Okay, but in the meantime, and the other thing is really, you always have to see. After you make a calculation, you have to see whether what you have makes sense or not. So we have 30 meters per second. Meters per second. Plus that, then this side you've got 9.8 rm meters per second squared. So that's what you have there. And of course, we do the same thing we've been doing. We drop off the units so that we've got something which is more compact. Okay, there. So if you expand, and simplify, expanding and simplifying, and so this side we get 30t, plus 60, you got 30 multiplied by 2, that is 60. Then you have that one, the half times 9.8, that gives you 4.9. Then you got the T2 plus T2, I thought. Get something which looks like that. So the 30 here multiplies the T, you get 30T, then the 30 times 60 times 2, get the 60 half here, then the half times 9.8, you get 4.9. Then this is T plus T2 square, you have you've got that. Next we proceed to do the same expansion, the stuff in the brackets, so that will give us what? Get t squared, then plus 2t plus 2t plus 4. Which is that bit. I expand and get that. And of course, that gives me that gives me 4 inside. Yeah, this plus that. I expand, then so I end up having plus civilian. I think we have something like this. This times this times that, this times that. So how much do we get for 4.9 times 4? 4.9 times 4 is how much? 4.9 times 4.
$19.6.
19.6.
Yes.
Okay, then 4.9. Okay, that's another 19.6, I think. Same. 19.6. Like that. Then here we have this. Then you've got that. Then you've got this bit. You've got that bit. So we write whatever we're doing. Plus 30. 30 plus we'll see if what we have done is correct. Then if we have to redo it the other way. Especially if we get a negative time. If we get a negative time, then it means that we have to redo the things we've done the other way. This. So this gives us how much? $30 plus 19.6.
$49.6.
49.6. Then 60 plus 19.6.
79.6.
79.6. Okay, so what S2 is equals to 4.9 t squared plus 49.60 plus 79.6. So the next bits we need to equate S2 and S1. We need to equate S1 and S2 for an overtake to occur. I can see a situation where we're getting a negative time, so we might have to redo what we have done. It goes to this. Yeah. So this speed and this speed is the same on both sides. So we end up having so we cancel out then, or you subtract. You could say take subtract 4.9 t squared on both sides. Gets and do that. Get a 0 minus do this, we subtract the same quantity from both sides. So one side you end up having a 0. Get a 0 like that. So we end up having this gives us a negative time. So the expression we used for the time is not correct. So we end up having 49 minus that. From 6 then 49.6. How much? Oh, sorry. How much time do you get? How much time do you get?
Negative 1.0.
Yeah, negative 1 point something.
Negative 1.604.
1.604.
6.
Okay. Now, clearly, this time is not correct because our time is negative. Okay?
Hello, sir.
Yes?
Yeah, I've got a question, sir. When do we consider gravitation acceleration?
What?
As in negative, when do we consider it negative or gravitation acceleration?
When do you consider acceleration to be negative?
Exactly.
When you're moving away from the surface of the earth. When you're moving away from the surface of the earth, your acceleration is negative. When you're moving towards the surface of the earth, your acceleration is positive. Okay, so clearly, the expression of time we used is not correct. This one here. So we need to change this expression so that we try to use t minus 2, and let's see what you get for that. Okay? So let's go back. So we have t minus 2. Yeah. T minus 2. So these are some of the things you're supposed to be aware of as you're working out some of these problems. You might be seeing a problem for the first time. Then, boom, your time is negative. That should tell you something is wrong. Okay? Because time is always positive. So, that would be there, t minus 2. So, I've proceeded, as you are seeing on the screen. I'm changing my t plus 2 to t minus 2. Because I know these times are related. The first time for the first ball and the time for the second ball, they are related. Okay. So here, t minus 2, t minus 2. So it looks like, I think what makes more sense now is later means minus, and then earlier means plus. So I think that's what makes more sense now. Later minus, then earlier plus. We should have a more meaningful answer by doing this. So that will be minus there, then minus here, minus here, 60 here, then t minus there, plus there, then minus 4, minus 60, plus 4. Okay, here, minus 60. When you do the expansion, 30t minus 60, then 4/9, t minus t, then you've got 30t minus 60, plus this minus t plus 4. Then you end up having this here, which I have here. Then I need to modify this. And of course, there's nothing wrong with not getting the answer in the first attempt. You just have to find out where it could have gone wrong. Okay, that gives me minus 60 here, minus 60 over 9, minus 19, and that. There. So here I'm supposed to have, where is that? So here, instead of 30, it's supposed to be 30 minus 9.6. Then this is supposed to be minus 60 plus 9.6. There. So 30t minus 19.6 is how much? 30t minus 19.6?
10.
How much?
10.4.
10.4t. Then the other one minus 60 plus 19.6. How much is that? Minus 60 plus 19.6.
Negative 41.6.
Negative 41.6. Okay, so now we equate them. The S1 and S2.
On negative 50 plus 19.6, Isn't it not negative 40.4?
So-
0.4.
Which one?
Negative
The one-
41.4.
It's supposed to be how much?
Negative 40.4.
40.4?
Negative 60 plus 19.6, negative 40.4.
Like that? Like this?
Yes.
Okay. So, we equate on both sides. Then we subtract. So after equating on both sides, we do the subtract thing. Okay, so I subtract this side. This side still becomes 0, but this side also there's 4.9 t squared minus 4.9 t squared. So that's going to disappear. We're going to remain with this bit here. We're going to remain with this bit here. Then you take the negative part to the other side. So now the sign that we're going to get something good is looks like you're going to have a positive sign. Yeah. 10.4 t equals to 40 points. That's that is going to give us so how much is that? Okay, 3.88, and that's, I think that's the answer you also have in your tutorial sheet. 3.88 seconds. Okay. So that is the correct answer. So the issue we had in terms of mathematics and time was, what does later mean? So in this case, we found out later means whatever the time was minus 2. Earlier means whatever the time is plus whatever it is. So we started with a plus, then it gave us a negative time, which is not correct. Okay, so we decided to use the other expression of time, t minus 2, and we have found out something which actually makes sense. So basically, the overtake happens after 3.8 seconds. Are we clear? For you to overtake, you need to cover the same distance. Sorry? Are we clear?
Sure.
Yeah, so for you to overtake, you need to cover the same distance. If someone has not covered the same distance as you, there is no way they're going to overtake you. The only difference is the time. So if they start later than you, so it's like you have seen, it's t minus 2 minus whatever amount of time they have started later than you. Okay. Alright, so question number 3 is done, unless people have got questions on what we have done and how we have done what we have done in question number 3. If not, then we move on to question number 4, which is a projectile problem. You fire a projectile 35 degrees above horizontal with initial velocity of 200 meters per second. It lands in a valley 300 meters below the launch point. What is the time of flight of the projectile, and what is the range of the projectile? So it's like I don't know if people can somebody explain what is actually happening here, so that I can see if people understand what's going on. There's a horizontal surface. In that horizontal surface, on the other side, there's a valley. Okay? And the valley is how deep? How deep is the valley? From the launch point, how deep is the valley?
300 meters.
Yes. So basically, it's like you're on a flat table. Then on the other side of the table, how high, how deep the table is, or how high it is, like 300 meters. So you launch something on a table, but it doesn't land on the table. It lands in the valley. Okay, 300 meters below the valley. So there are basically 2 points. There parts of this journey is that one. When the projectile is launched, it has to go up. It reaches maximum height. Then later on, it comes down. Same level. I think if you guys can give me some 15 minutes, I sketch something, then scan it, then I put it here so that we can see what you're talking about. Okay? Give me some 15 or 10. Okay, let's see. It's 10:10. So let's come back at, don't kind of like closing, come back at 10:20 so that I sketch something, I scan it, so that we've got a picture we are looking at as we follow this projectile thing. Okay? I think it will be easier. It will be easier for me to, as we do the calculations, and that's what I encourage. You need to be able to make a sketch as you try to solve a problem like this. All right? So come back at 10:20. Are we clear? Hello? Yeah, come back at 10:20 so that I make some sketches. I scan them, then I put them on the computer so that we can see what you're talking about. Because this question doesn't have a sketch, we can follow. Okay? All right. So 10:20. I'll pause the recording so that, yeah. And you can have tea in the meantime, or breakfast if you didn't have breakfast. Okay? Let me make some sketch.
answer. Good morning.
Hello.
Yes, sir.
Yeah, let's come back. The other people. Okay, let's see what we can do now. Just a minute. In a screenshot. Just a minute. I'll be done very soon. Okay, so this is what you're talking about. It's quite big. Then I need to another one. Okay. Can you see the figures? The one for question number 4 is this one. Hello?
Yes, you can see.
Okay, so let's get started with this one. So basically, from the question, what we're being told is you fire a projectile 35 degrees above the horizontal with initial velocity of 200 meters per second. It lands in a valley 300 meters below the launch point. Below the launch point. What is the time of flight? Let's send a message to the other people who Yes, so what is the time of flight for the projectile and what is the range of the projectile? The time of flight is basically saying how much time does it take to move from this point to there, all the way down to here. This time, what time does it take? Like that, all the way up to there. Okay, so the one thing you notice is this thing, a projectile, the one unique thing about projectiles is projectiles move in 2 different directions at the same time. A projectile moves along the horizontal direction, a projectile moves along the vertical direction. A projectile moves along the X and along the Y direction at the same time. Okay, that's what a projectile has going for it. It moves in 2 different directions at the same time. If a projectile is going to move from there all the way up to that point A, then all the way up to there, this time, the time to move from here, from the launch point to maximum height and come back, this time is the same. Because the distance from here up and coming down is the same, and we are going to be able to show that. Okay, then once we know how much time it is taken from there, we know how much vertical distance it's traveling from this point, from point B to point C. The distance is 300 meters. So if we know the speed here, vertical speed here, then it covers 300 meters. We know the acceleration. We can find out how much time it's going to take to cover this distance. So basically that's what we're going to do. The other thing to notice is along the x-axis, along the horizontal axis, for a projectile, there is no direction. Sorry, there is no acceleration. The acceleration of a projectile is only in the y direction, in the vertical direction. When the projectile moves from here up, its acceleration is 9.8 meters per second. It's moving away from the surface of the earth. Therefore, it's negative 9.8 meters per second. When the projectile reaches point A, then it starts coming down. It's moving towards the surface of the earth. Therefore, its acceleration is plus 9.8 meters per second. So from this point here to A, acceleration is negative 9.8 meters per second. From A to B, acceleration is positive 9.8 meters per second. From B to C, acceleration is still positive 9.8 meters per second. That is one of the things you're supposed to be aware of about projectiles. They have got acceleration in the y direction. They have got no acceleration in the x direction. Okay, so for us to get started, what we need to do is we need to break down, we need to decompose the velocity, the velocity of the initial velocity of the projectile. then the 200 meters per second of the projectile, we need to break it down into an x component of the initial velocity. We also need to break it down into a y component of the initial velocity, so that we know how much is the velocity in the y direction, how much is the velocity in the x direction. That's what we need to do. We need to decompose or break down the velocities. So, for us to proceed, you need to be aware that a projectile moves in two different directions at 90 degrees, at two different perpendicular directions, perpendicular directions at the same time. Okay, x and y direction, x and y directions. So that's the first thing you need to notice. Projectiles move in two different directions at the same time. Next bit is we need to know how much is the initial velocity of the projectile in the x and y directions. So we need to know how much this is. Initial velocity u in the x and y directions. In the x direction, initial velocity denoted ux is, how do you find ux? From the angle. How do you find the initial velocity in the x direction? We're looking for ux. How do you find it?
The velocity plus the angle.
Yes. Again, ux is equals to the velocity, which is u, initial velocity, then cos theta. That would be, the velocity is how much? How much is the velocity?
200 meters.
200 meters. And how much is the angle?
35 degrees.
35 degrees. This gives us how much? 200 meters per second cos 35 degrees. How much is that? How much we get? 153.63.
163. Yes, 163.8.
0.8 meters per second. Okay. Then the other thing we do is we note that there is no acceleration in the x direction. If there's no acceleration, therefore the final velocity and initial velocity of the projectile in the x direction is the same. So basically we are saying in the x direction, so we are saying ux is equals to vx, which is equals to what we have found already. That's there, this one. So we note that there is no acceleration in the x direction, therefore the final velocity and initial velocity of the projectile in the x direction is the same. Basically that ux is equals to vx is equals to 136.8 meters per second. Is this clear? Is this bit clear? Are we clear on this bit?
Yes.
Okay, so we move our attention to the y direction. We want to find out how much the initial velocity is in the y direction. In the y direction, the initial velocity projectile is uy is given by how do you find ui? How do you find ui? The initial velocity in the y direction.
It will be the velocity sine theta.
Yes. That is u sine theta. And when we make our substitutions, our u is how much? How much is our u?
200 meters per second.
200 meters. And how much is our angle? How much is the angle?
35 degrees.
35 degrees. So there. 200 sine 35 degrees. How much do we get for that?
$114.7.
100
14.7.
14.7. Okay. So in the y direction, the there is acceleration depending on the direction. The projectile is moving. Where are we? Yeah, in the y direction there is acceleration depending on the direction in which the projectile is moving. When the projectile is moving away from the surface of Earth, the acceleration is A is equals to minus 9.8 meters per second squared. And when the projectile is moving towards the surface of Earth, acceleration is plus 9. Okay, so that's one thing you're supposed to be aware of. In the y direction, if your projectile is moving away from the surface of the Earth, then the acceleration is negative. That negative acceleration is going to result in your projectile reducing its speed until it comes to a stop. When the projectile is moving towards the surface of the Earth, your acceleration is positive. That results in an increase in the velocity of your projectile in that particular direction. Okay, the next bit is we consider only motion in the y direction, and momentarily, I don't know if the spelling is correct, momentarily ignore the motion in the x direction. So we just look at motion in the y direction. We will consider motion in the x direction at the end. That's one of the things we do. So we now just look at what's happening in the y direction. Here, we just look at what's happening in the y direction and momentarily ignore what's happening in the x direction. The reason why we ignore what's happening in the x direction is because there's no acceleration. We know what the velocity is at each and every point in the x direction because there is no acceleration. The velocity at each point is equal to the initial velocity in the x direction, which is what we have already found. So there's nothing interesting happening in the x direction. The interesting stuff is happening in the y direction. Are we clear? Are we clear about our choices?
Yes.
Yeah, so we just look at what's happening in the Yeah, we just look at what's happening in the x direction, in the y direction. Okay. So the first thing we are interested in time of flight. Okay, we are interested in time of flight. So we need to find out how much time it's going to take for our projectile to move from the launch point to A, the maximum height. When you find that time, then we also need to find out how much time it's going to take from A to B. Then how much time it's going to take from B to C. Then once we find these 3 times, we can add them. When you add these 3 times, they give us a time of flight. Is that clear? We need to find the time from launch to maximum height. From maximum height, which is A, to B. Then the time from B to C. We need to find these 3 times. Are we clear?
Yes, sir.
Okay, so let's find the time it takes our projectile to reach maximum height. Okay. We first need to find the time it takes our projectile to reach maximum height in the y direction. In the y direction. This time is sometimes referred to as rise time. So as rise time, and is denoted T1. So we need to find T1. We know, okay, yeah, here. We know that the initial velocity in the y direction from the launch point is, we have this guy uy is this guy, uy is that, and the final velocity at maximum height. How much is the velocity of the projectile at maximum height in the y direction? How much is the velocity of the projectile at maximum height in the y direction?
0, sir.
Yeah, it's 0. So 0 meters per second. So we know the initial velocity, we know the final velocity in the y direction as it's moving towards maximum height. Since projectile is moving away from surface of Earth, the acceleration is A is equals to this minus therefore we can get rise time from the following formula. Just a minute. V is equals to U plus 18. That. In the y direction, this formula becomes the following. Uy multiplied by 81. That's what it becomes. It becomes this. So this formula here in the y direction, it becomes this. Vy, the final velocity in the y, is equal to the initial velocity in the y plus the acceleration times the time. Substituting, so we substitute the values we have. Substituting values, we get our Vy is 0. That's what we've been told. Zero. Our Uy is not. Our acceleration is that bit. Where are we? Oh, there we are. Next, we drop the units. Dropping some units. Dropping units. We get we get that, and that gives us that. Where are we? Okay, there we are. We write this as there 9.8 t plus equals to 114.7. Then you find our t1. We get T1 as much does that give us? 114.7 divided by 9.8.
11.7.
11? Point what?
11.7.
11.7 seconds. Okay. So you find how much time it has taken to go up. Takes 11.4 seconds. The next thing you would do is you want to find out how high it has actually gone. The maximum height. Next, we get maximum height. It doesn't say that find maximum height, but it's part of the process of finding out, because now we need to find out, why do we need maximum height? We need maximum height because of here. We know how much time it has taken to move from here to A. We want to find out how much time it's going to take from A to B. But for us to do that, we need to know the height to which this thing has gone. Okay? So that's why we need to find the height. So we can use that. Next, we get the maximum height. Maximum height reached by the projectile using the rise time as follows. S max S is equals to, quickly we can, this is something you can do quickly, 1/2. We know U plus V multiplied by T using this formula. Using a very, very simple formula, you can find that. Where is that? Here. S is equals to half U plus V divided by T. Now we are in the y direction. Okay. So in the y direction, the maximum height is obtained as, so this formula kind of changes a bit, gets modified slightly, but it's the same, it's still the same thing. S max, there's a bit which is missing. Max is equals to uy plus vy times T1. So this is what we're saying. You can find the maximum height to which a projectile has risen to using this simple formula here, S max. Because remember, we used a formula like this earlier. It gives a very good approximation of how much distance has actually been covered. So in our case, we are looking for maximum height. We know the initial velocity in the y direction. We know the final velocity up to maximum height. The final velocity is 0 meters per second. And we also know the time it takes to reach maximum height. So we can estimate how much distance or height has actually been covered. So we substitute. Is it clear what I'm trying to do and how I'm trying to do it?
Yes.
Okay, substituting. We got our U max. Our U is what? Yeah, that's our U. Uy plus Vy. Vy is 0. Then T1, we just found out T1. There. That gives us just a bit. So how much is S max? How much is S max? Where are we? How much we get for S max? Half times 114.7 meters per second times 11.7 meters per second. How much we get? Huh?
670.995.
Wait first, 670 point?
Yes.
Point what?
995.
995. Okay, that's like 671, I think. So basically that is our maximum height, approximately that much. Okay. So now that we know that actually our projectile goes to a height of 671 meters, when it comes back from A to B, it has to fall through the same distance it went up. Is that clear? Are we clear about that? If our projectile is going to a height of 671 meters, when it's falling, it has to fall through from A to B, it has to fall through this distance. Okay? Is that clear?
Yes, sir.
Okay. Now that I'm typing something, now that where is that? Okay. We know that our projectile rises to a height of 671 meters. It has to fall through the same height. It has to fall through the same height as it retains from maximum height to the launch points. Yeah. There. Okay. In the y direction, at maximum height, the projectile has an initial velocity How much is the initial velocity as the projectile is coming from maximum height? What is the initial velocity?
Zero.
0 meters. 0 meters per second. And covers and falls through a distance. And falls through a distance of S max. Distance of S max, which is equivalent to the distance of S max while going towards the surface of the earth. Surface of earth. That is, therefore, acceleration is A is equals to 9.8 rm meters per second squared. Is this argument I've put here clear? When our projectile is at maximum height, then it's coming from maximum height. The initial velocity is 0 meters per second at maximum height. Then it's going to fall through a distance of x max, which you already know. Then it's coming towards the surface of the earth, which means it's accelerating at 9.8 meters per second. Is that clear?
Yes, sir.
Yes. So we can get there. The time of 4 denoted T2 from the formula again. Just a minute. S is equals to UT plus of 80 squared. There. We use that formula. So we modify it in the y direction. Y direction. This formula becomes S max is equals to uy T2 plus that T2. Where is it? Oh, yeah. So this is what we end up having. This formula in the y direction becomes this. We're talking about S max. The S is the height through which your projectile is going to fall through, which is the same height it went up to. Then the uy is your initial velocity of a projectile at maximum height, which is 0 meters per second. Then we know that T2 is the time of 4. That's what you're looking for. Then the A is the acceleration. It's coming towards the surface of the earth, therefore the acceleration is going to be positive 9.8 meters per second. Okay, substituting. Good. That's the minute. So S max. Not UI 0. Then A. That, get that stuff there. Then same thing we've done, we drop off some units of units. So we get a more compact form of this. Get that, and that gives us what? There's a 0 multiplying something there, so that would be a 0. Then there's a half multiplying a 9.8, that gives us a 4.9. That, and that gives us that. Okay, that gives us that. Then we divide on both sides by 4.9. Brilliant. Two squared power 2 is equals to different 671 divided by 4.9. How much is that? 671 divided by 4.9.
That's 136.93.
Just a minute. 136 point 3.
93.
9. Okay, just say 9. The next is square both. Take the square root. Take the square root.
11.7.
Square roots on both sides. Both sides. You get T2 square roots of this guy. say 11.7 seconds. Okay, so you see something here. Our projectile, to go to maximum height, what is that? Here. From launch point to maximum height, our projectile takes 11.7 seconds. Then from A to B, our projectile takes another 11.4 seconds. The reason why it takes 11.4 seconds, 11.7 seconds, where T1 is equals to T2 is because the projectile rises to the same heights through which it falls. So the height to maximum height, the distance to maximum height and the distance it falls from maximum height to the level where it was launched is the same. So if we kind of like, I didn't want to say it before, we could have just, the moment we found out, oh, this is our T1, we could have said, okay, T2 is also going to be equal to T1 because we knew that the projectile is going to rise to the same height, okay? With this velocity, with this time, T2, we can also find out what is the velocity in the y direction of the projectile at B, okay? Let's find out what the velocity of the projectile in the y direction is at B. We can do that, and it's very easy. So we want to find out what the velocity is at this point, because we need this point, we need to know the velocity at this point for us to do this, find out how much time it's going to take from B to C. Okay, so the velocity at B next, we find out velocity of the projectile in the y direction at point B, i.e. when the projectile returns to its launch point in the y direction. We use the formula V is equals to U plus 18. There. So that formula, so in the y direction, as the projectile falls from maximum height.
Sir,
yes.
we can't see the pin document.
Which document can you see?
The one that you shared.
The sharing has stopped.
Yes.
Oh. Okay. So in the y direction, as the projectile falls from maximum height, this formula, can you see it now?
Yes, we can see it.
Okay. Sorry for that. Vy is equals to Uy plus this. That's what it becomes, this. We know how much Uy is, 0, and we have found the t. So substituting, we got our Uy is 0 meters per second. Our acceleration is 9.8 meters per second squared. Our t2, we have found that is 11.7 seconds. Thoughts. So we do the same stuff we've been doing, kind of drop some units. Excuse me. We got and that gives us a VY of how much? How much is our VY?
That is
114.66.
How much?
114.66.
114.666 something, which is just 1.817 meters. There. 114.7 meters is very familiar to you because 114.7 meters is actually, if you go back up here, that is what we started with. This guy is actually your Uy. When you're going up, Uy, yeah. Uy is 114.7 meters per second. That becomes your Vy. So when your projectile goes up like this, from here, it goes up to maximum height. It takes a certain amount of time. If your projectile is going to fall through the same distance it went up from A to B, if that's the same height, then the rise time and the fall time are going to be the same. That's the first thing. T1 is going to be equal to T2. So this side T1 is 11.7 meters. The other side T2 is 11.7 meters. That is not the only thing which is going to be the same. It is also the velocity here. When the projectile was going up, the initial velocity was 114.7 meters. When it's falling, it reaches the same point, going in the opposite direction. The velocity is the same here, 114.7 meters. Is that clear?
Yes, sir.
Okay, so that's something you're supposed to note as you're trying to solve a projectile problem. Deliberately, I have gone the long way so that you can see how each part of the question is related to the next, how things are related. In the exam, probably you can do things faster, but it will be helpful to know some of these facts, like T1 is equals to T2, Uy is equals to Vy at that particular point. If it's going this way and coming this way, the velocity is the same. Okay. Now that we know what Vy is, from Vy, from B here, from this point B, we know the velocity here. So this velocity at B becomes our initial velocity for the journey from B to C. Okay? So our initial velocity from B to C is now the 114.7 meters. The distance which is going to be covered is going to be 300 meters. It is still going down this way. It's still going down this way. It means that the acceleration is 9.8 meters. Okay? Is that clear?
Yes, sir.
Yes. So it covers a distance of 300 meters. The initial velocity is what was Vy, which is 114.7, and the acceleration is 9.8 meters. So we can use the same formula we have been using. S is equals to ut plus that. In this case, the only problem in this case, slight problem, is our thing kind of becomes a bit quadratic. That is the only hiccup. Okay? It kind of becomes quadratic. However, what we can do, no, let's go the same quadratic way, it's fine. There's nothing to be scared of with quadratic. We have the quadratic formula which can give us what the time is supposed to be. Okay? But there's an easier way which I don't want to do, but I can explain it at the end. Okay? Okay. From the launch points in the launch points going in the opposite direction, going in the opposite, in the negative direction, in the negative direction, we get we have the initial velocity at point B as Uy is 114. I think I will still have to show the other way. Meters per second. Meters per second. And acceleration is, however, the approach I've taken is the most clear approach to what's happening, so that you, even when you're asleep, you can explain, say, fine, I can do this problem like this, and the distance under the launch point is S equals to 300 meters. Oh no, this is a problem. Is it? Okay, no, it's fine. Meters. So we get time of 4 from B to C as follows. Um, 300 S is equals to UT plus frog 1 over 2 AT squared. What does happen? In the y direction, this becomes this formula becomes S is equals to uy T3 A T3 that's our UI in this case, so we substitute now. So sub again. So I have 300. In this side you have got 114.7. Then 4.9, sorry, 9.8 squared. What happened? Just a minute. Okay, we have that. Then dropping of the units. That. Okay, you get this. Then of course that becomes 4.9. There. Then thing appears to be stuck. I don't know. The other things are showing. Okay. This, as you can see, looks familiar. Get the 300 this side. There.
Oh, we can't see anything. It's dark.
It's stuck. Just a bit. Just a minute. Okay, so we had this. The distance it falls through is 300 meters. The initial velocity 114.7. Then T3, then half times that. That gives us basically what you have in 300, 114.7 T3, then plus 4.7 T3 squared. Then we take the 300 that side. Then you end up with this 4.9 plus 114.7 T3 plus minus 300. That is the quadratic equation. Okay, can you see that?
Yes, sir.
Okay, so that's the quadratic equation. We can solve using a quadratic formula. Can you still see the presentation?
No.
No?
Yes. No.
Okay.
Yes. Visible now.
Okay. I seem to have I need to minimize the presentation first to write something. Can you still see it now? No?
No.
Okay, I need to write some because my. Okay, I need to maybe end this a bit, then restart it. Then we start somewhere. Just a minute. Okay. Yeah. Okay, so this is the quadratic equation. This is a quadratic equation that can be solved using the quadratic formula. Again, so x is equals to minus b plus or minus square root b squared minus 4as divided by 2a is a quadratic equation of the form ax squared plus bx plus c equals to 0. Okay, can you see this?
Yes, sir.
Alright, so in our case, x is equal to T3 A is equal to 4.9, B is equals to 114.7, then C is equals to minus 300. Therefore, we get that. So this is what we have in our case. X is T3, A is 4.9, B is 114.7, C is minus 300. So we get T3 T3 is equals to as B, which is 114.7. B squared is 114.7 squared. Then A is 4.9. Then that is minus 300, and the whole thing divided by 4.9. Like that. So the whole thing in the square root, there is 114.7 squared. Then just a bit, there is a minus. There's a minus there, so we need to modify that a bit. That's going to be, before you do the calculation in the square root, this is going to be a plus. We're going to have a plus there. Then at the bottom here, you're going to have a 9.8. Like that. This negative and that negative. So how much is the stuff in the square root? How much is everything in the square root?
Finding 137.9.
How much?
Just for the square. 137.9.
37?
Yes,
Point
0.9.
0.9. Okay. Can someone else confirm that? Can you get a confirmation that everything in the square root is 137.9?
I've done the calculation again, still the same answer.
Sorry?
I've done the calculation again, it's still 137.9.
Okay, then you're going to proceed. So the first thing you're going to do is want to find, there are two values. But if you work out if you get like before, if you get out negative values of time, then those don't work. So we're only going to focus on working out positive values of time. So we focus on getting only positive values of time which have a physical meaning. Okay. Therefore, we get this expression becomes, if our interest is only to find positive time, then it becomes oh my god, plus here, we get a plus. And how much will be our time this time? Here, 114.7 plus that one divided by 9.8. How much will be the time?
Finding 2.36 seconds.
2.36?
36, yes.
Okay, that is basically 2.4. Approximately 2.4 seconds. Okay, so with that, we now have the times for the three parts. Okay, we have the time for the three parts, so we can work out. We can now get the flight time as TF T1 plus T2 plus T3. That's what I thought. So that will give us 11.7 plus 2.4. How much you get as flight time?
25.8 seconds.
Yeah, so we get 25.8 seconds. Is this clear? What you have done?
Yes, sir.
Okay. Alternatively, another alternative to finding the flight time, an easier alternative, okay? An easier alternative. This one it's very clear, but there's a complication of you having to solve a quadratic here, okay? The other way to do this is when you go back to your diagram here. When you go back to the diagram here, from A to B, you say, okay, I'm not going to work out from A to B, I'm going to work out from A to C. Exactly, can you see that? instead of you working out the time from A to B, then the time from B to C, you say from the top there, I'm going to work out the time from the maximum height all the way up to the value down there. Now, for this to work, you know that at maximum height here, the initial velocity is 0. Then when you reach down here, the initial velocity is not going to be 0. However, the height has to change. Okay? In this case, the height is going to be 300 meters plus the height to maximum height, the 671 meters. That is going to be the distance your projectile is going to move. Is that clear? That way you're going to obtain a combined time for A to B to C. That is another way. You can try that. Okay?
So, sir, you are saying at point A our velocity is going to be 0, and then...
Yes. At A our velocity is 0 in the y direction.
Okay, and then the maximum height, you're going to add it to the 300.
It's 671 plus the 300 meters, the height. We can try to do this. So that instead of having what we have T2 plus T3, we can just have T2, which is a combination of T2 plus T3. Can we try that? To show that we actually get the same thing.
Yes, we can try that.
Okay. So I'll say alternatively, the times T2 and T3 worked earlier can be bundled into one 4 time, bundled into a single 4 time starting from maximum height going all the way to below the valley, below the valley. Okay, yeah, that's what I'm saying. The ones you have with T2 and T3, you can bundle them up into a single 4 time, which starts from maximum height, goes all the way below the valley. Okay. In this case, the distance, the height of 4 is given by combination of the height to maximum height and the distance and the depth below valley. Below the valley. So we get S is equals to 617 meters plus 300 meters, which gives us 971 meters. That's Are you seeing what I'm saying here? The height through which, if you just consider it from maximum height all the way up to where it falls, when it hits the ground, it's going to be the distance it would have traveled is 671 meters plus 300 meters, which gives you 971 meters. The initial velocity at maximum height in the y direction is uy 0 meters per second, and the acceleration is a equals to 9.8 meters per second squared. Then uy is 0 meters per second, acceleration is 9.8 meters per second, then you've got s. So we can find the combined time of four using the formula again. Equation is equals to ut plus 1 over 2 80 squared. I'm going to put a small c here. Say it's a combined time of 4. The combined time of 4, I'm going to call it TC. TFC. I'm just going to call it TC for combined. Just a minute. Y TC is the time, combined time of 4 TC. So in this case, substituting that this one is 0 meters per second. The other one is here 9.8 meters per second squared dot. There. Then dropping off the units. You get that? Are we clear up to this point? Up to here, are we clear? Okay. Next, you multiply that, whatever it is that you have by 0 there, you get a 0. Whatever time you have, you multiply it by 0, you get a 0 this side. You get a 0 here. Here you get a 4.9. So you can see here, already we have avoided, when we do this, the advantage of doing this, combining you just look at one single 4 time. The advantage is you avoid having to work out a quadratic. If the way we did it, we split the times, the stages. If you split it into 3 stages, somewhere you have to work out a quadratic. Okay? But if you combine the 4 time into one single thing, you avoid working out a quadratic, which is a much better approach, in my opinion. But you have to know what you're doing, because when you do that, you have to remember that the distance is no longer the same. You have to combine the distances. These. Then now we do the normal thing. We divide by 9.8. We divide by 4.9 on both sides. Both sides. How much do you get when you do this? 971 divided by 4.9.
That's 198.
Just a minute. 198. That's all?
Yes.
Okay.
198.16.
188.2.
188.
198.2.
Okay, 0.2. Okay. Next we square root. Take the square root.
14.07.
Just a minute. Root on both sides. I still need to write. We get TC as a mark.
Okay.
Just a minute. Square root of okay. So that gives me how much? 14.1?
14.1.
14.1?
Yeah.
Okay. Now we can work out the time of flight. We can now work out flight time. F as again equation plus the T1 plus TC. If everything you've done is correct, our answers should match. $11.7 seconds. Then the other one is 14.1 seconds. much we get?
That's 25.8.
5.8 seconds, which is the same thing we had before. Is this clear? Are we clear?
Yes, sir.
Huh?
We are clear, sir.
Okay, so as we can see, this approach where you combine the maximum heights projectile goes up to and the depth below, when you combine that, this approach is much faster. It gives you your TC much quicker. Then you combine your T1 plus TC, you get your flight time. If you can't do this, then you have to go through this, where you split your thing in stages. But also the other thing to do is you could definitely quickly guess to say T1 is equals to T2. So you could have combined the 11 point something, 11.7 plus 11.7, that gives you the first part from here all the way up to there. So that's a quick one, okay? Then the next quick one you could do is, the velocity here. What's the velocity here? The velocity here is the velocity here, except in the opposite direction. Uy and Vy at B are the same. So you could use that to work out a quadratic, which would give you your 4.2. Then you'd combine. Okay? So there are basically about 3 ways of working out this problem. We have looked at 2 ways. The other one is you could combine T1 plus T2. Say that T1 is equal to T2. So you're from all the way from the maximum launch, maximum height, and coming down to the same level. That will be your T1 plus T2. But T1 plus T2 is T1 and T2 are equal to each other. Okay? Is that clear?
Yes.
All right. The last bit of this question, we have gone beyond our time. The last bit says what? What does the other question bit say? What is the range of the projectile? Range is very easy to find. Range is equals to ux times time flight time. We have found the flight time in 2 different ways. So the range is the easiest to find. The range of the projectile R is given by, again, equation. R is equals to ux multiplied by flight time. There. The range is equals to ux multiplied by the flight time. Ux doesn't change. We know the flight time. We found the flight time to be 25.8. 25.8. Then ux yeah. So how much we get? As the range? What is the range?
That's about 4,226.
4,000?
226.
226.
0.04.
226. Okay. Meters. Are we clear?
Yes, sir.
Alright, I think we should stop here today. We have shot way behind our time by close to 50 minutes. Okay, so we stop here. When we meet on, I give it guys a task to come up with a time for us, because this week we're not going to be able to meet at 18 hours on Wednesday, Thursday and Friday. Somehow I suggested we meet at 12 hours, from 12 to 13 hours, Wednesday, Thursday and Friday, so that we can finish up these other things. Okay, so I will upload the PDF to Moodle. Then also when I have time during the course of the day, I'll upload the video to YouTube. Alright, so see you tomorrow. Discuss how is 12 hours. Yeah. Okay, people have left already. Okay.